Hi everyone, my name is Elena Magallon and I'm on the 6th semester of Mechanical Engineering at CETIS Universidad in Mexicali, Mexico. In this video I'm going to show you how to do the workshop number 11 with title Using Lists and Groups. The objective of this workshop is the following. Become familiar with the tool that is used to create and manipulate lists of entities, node, element. The criteria that is used to define a list is material property, element thickness, and applied temperature. The operation that is used to manipulate the list is intersection. Here you can read the problem description. First, we're going to create a new database. We make a click in New, and remember to create a new folder with the same name as your file. We put the file name, in this case it's going to be fairing, and then we click OK. We're going to set the tolerance to default, and remember to make sure that the analysis code and analysis type are set to MSC.Nastran and structural respectively. Then click OK. Then we're going to create a model geometry. We're going to make a click in Geometry and put Create Point and XYZ. Turn Auto Execute off. Enter the following points coordinate list 30, 0, 0, and then click Apply. Then we're going to change the object to curve and the method to XYZ. Turn Auto Execute off and enter 0, 120, and 0, and 50, 40, 0 under vector coordinate lists and origin coordinate lists respectively. Then we're going to click Apply. We're going to make a click on Show Labels icon and click on Point Size icon to increase the point size. Then we're going to go back to Geometry and enter Create, Curve, and Point. Remember to turn Auto Execute off. Click on Point 1 under Starting Point List and click on Point 2 for Ending Point List. Then click Apply. Illustrated here are curves that represent the basic geometry for the fairing. These curves will be revolved 360 degrees to get the final model. We go back to Geometry and we put Create, Surface, and Revolve. Enter chord 0.2 for X's and enter 360 for the total angle. Remember to turn Auto Execute off. Shift select curves 1 and 2 in the curve list and then click Apply. Make a click in Menu and then in Viewing. select the angle option. Enter 30, 0, 0 under angles. And then click apply. Make a click in menu again. And then a click in display. Choose the geometry option. Enter the number 3 for number of display lines. Then click apply and then cancel. We're going to create a mesh seat. We're going to create a finite element mesh so that 4 node quad elements are created every 10 angles along the circumferential edges. We're going to make a click in meshing and make sure that create mesh seed and uniform and selected. We're going to enter the number 36 and number of elements. Turn auto execute off and select the top circumferential edge of the fairing, surface 1.3. And then click apply. We're going to make another click on meshing and make sure that create mesh seed and one-way bias are selected. Select L1 and L2 and enter 7 and 10 for L1 and L2 respectively. Remember to turn auto execute off. Under curve list, select curve 1 and click apply. Now we're going to enter 4 and 7 for L1 and L2 respectively. And under curve list, we're going to select curve 2. And then we're going to click apply. Now that the mesh seats have been created, mesh the model using Quad 4 topology. We're going to change mesh seat to mesh and make sure that surface is selected. Select Quad, Isomesh and Quad 4. Select the entire model by dragging a box around it. And then click apply. Remove the display lines by clicking on the display lines icon. Remove the labels by clicking the hide labels icon. Decrease the point size clicking on the point size icon. Mesh the horizontal edges of each surface with 2 node board elements. Click on Plot Erase icon and click on Erase under FEM. Then click OK. Then we're going to make a click on Meshing and make sure that Create, Mesh and Curve are selected. Set Topology to Bar 2 and Shift select the 3 surface edges as indicated. Then we're going to click Apply. Check the free edges of the model equivalence and then check the free edges again. We're going to make a click in Meshing, and in Action we're going to select Verify, Element and Boundaries. Select free edges on the display type and then click Apply. We are now going to select Equivalence, All, and Tolerance Cube. Then we're going to click in Apply. We're going to select Verify again, and Elements and Boundaries. Select free edges under Display Type and then click Apply. Now we're going to create a group called FEM containing only the finite element model. We're going to make a click on Group and select Create. Before this, we're going to make a click on Plot Erase icon under FEM, click Plot, and then click OK. Now we're going to make a click on Group and select Create. Enter FEM for the new group name and select Unpost all other groups. Change group content to Add all FEM. Then click Apply. Then we're going to create the first material for the model. We're going to make a click on Properties and then in Isotropic. Enter Alum 1 for the material name. Click on Input Properties. Select Linear Elastic and enter the following number. Once we have all the values, we're going to click OK. And then make a click on Apply. Now we're going to create the second material. We enter Alum 2 for the material name, and then we're going to make a click on Input Properties. Put the following numbers for elastic modulus, Poisson ratio, and density. Once we have all the values, we're going to make a click on OK. And then Apply. Now we're going to create a field. Make a click on the field icon and make sure that Create, Spatial, and PCL function are selected. Enter thickness for the field name. Then enter the following value for the scalar function and click Apply. Now we're going to put temperature for the field name and enter the following value for the scalar function. Then click enter. Now we're going to create element properties. Click on the front view icon and then make a click on properties. Make sure that create 2D and shell are selected. Enter prop1 for the property set name and then click on input properties. Click on Material Property Name icon and select Alum 1 from Select Existing Material. Then make a click on Thickness icon and select Thickness under Select Existing Field. Click OK. Now we're going to make a click on Preferences and select Picking and set Rectangle Polygon Picking to enclose entire entity. Then we're going to make a click on Close. Click on Select Members and click on the shell element icon. Select the top cylindrical portion of the fairing by dragging a box around the desired section. Click Add and then apply and then apply. Now we're going to create the second property set. Make a click on Properties and make sure that Create, 2D and Shell are selected. Enter Prop 2 for the property set name. Click on Input Properties. Click on Material Property Name icon and select Alum 2 from selecting existing material. Click on Thickness icon and select Thickness from Select Scalar Spatial Field. Then click OK. Then click on Select Members and select the bottom portion of the fairing by dragging a box around it. Make a click on Add, then make a click on OK, and then a click on Apply. Now we're going to create temperature boundary condition. We're going to make a click on Loads and make sure that Create Temperature and Nodal are selected. Enter temp for the new set name. Click on Input Data and click on Temperature and select Temperature from the Spatial field. Then click OK. Click on Select Application Region. Under Geometry Filter, select FEM. Click on Application Region and select the entire model. Click Add. Then make a click on OK and then in Apply. Don't forget to enter the new set name. Then we're going to turn off the temperature labels in order to get a better visualization of the model. Click on Display and select Load BCLM Props. Under Load BCS, remove Check for Temperature. Click Apply and then Cancel. Now we're going to create lists. Make a click on Tools, List, and then select Create. Make sure the FEM element and attribute are selected. Under Attributes, select Material. Under Existing Material, select Alum 1. Set the target list to A and click Apply. Then we're going to make a click on Properties, and we're going to make a click on Show. Under Existing Properties, select Thickness. Set Display Method to Scalar Plot. Select Current Viewport, select FEM, and click Apply. Then make a click on Tools, select List, and then Create. Make sure the FEM element and attribute are selected. Under Attribute, select Fringe Value. Under Fringe Tool, select Default Fringe. Change F and enter 0.98. Then we're going to select B for the target list. Then click Apply. We're going to make a click on Tools, List, and select Boolean. Click on the intersect icon. Click on Replace A. And then click Cancel. Now we're going to perform a final classification of the elements. Make a click on Load BCS. Make a click on Plot Contours. And make sure the temperature is selected. Select Temp from the existing set. Select Temperature under Select Data Variable. Select the FEM group and click Apply. Now we're going to make a click on Tools, List, and select Create. Make sure the FEM element and attribute are selected. Select Fringe Value and Default Fringe for for attribute and fringe tool respectively. Change F and enter 230.0. Select V for the target list. Click on Clear on the list B and click Apply on the list Create form. List A and B will be intersected again to create a list C. Make a click on Tools, List and Boolean. Click Clear. Click on the intersect icon. Then click on Add to Group. Enter common quads for the group name. Click Apply, then Cancel. Post the common quad group. This is a group of elements that satisfy all three of the conditions defined earlier. We're going to make a click on Group, Post. Select the common quads group under Select Group to post. Click Apply, then Cancel. Click on the ISO 1 view icon. Now we're going to create two new groups. We're going to make a click on the Reset Graphic icon. We're going to make a click on Group and then select Create. Make sure that Create and Property Set are selected. Enter prop1 group for the group name. Select prop1 under Property Sets and click Apply. Repeat these steps, entering prop2 group from the group name and selecting prop2 under Property Sets. Now we're going to change the display attributes. We're going to make a click on Display, Entity Color, Label, and Render. Select Group under Entity Coloring and Labeling. Select the Prop1 group under the Target Groups, and select Wireframe from the Render Style and select Yellow from the Shade Color. Click Apply. Select the Prop2 group from the Target Groups and select the Hidden Line from the Render Style and select Dark Blue for the Shade Color. Click Apply and then Cancel. Then we're going to change view and post the Prop1 group. Click on the ISO 3 view icon. Click on Group and then Post. Under Select Group to post, select Prop1 group and then click Apply. Then we're going to make a click on group and then post. Under select groups to post, select prop to group and click apply. Then we're going to post both the prop 1 group and the prop 2 group. Click on group, then post. Under select groups to post, select both and then click apply. Well, this is everything for this video. I really hope you like it. Don't forget to give me some thumbs up and go and check my other videos. Bye!